Good morning, everybody. This is Mr. Chapman here with another maths how-to video, this time on long multiplication. The long division video was quite a success, so a couple of people have requested that I do long multiplication as well. Camera, focus, focus, thank you. So, let's start with an easy short multiplication, just to remind ourselves what we need to do. We'll start with 43 times 5. Now, with short multiplication, of course, everything on the bottom row needs to be multiplied by everything on the top row. So, we have 3 times 5, which is 15. The units go in, and the 10 is carried over. Then we look at 4 times 5. Now, we say 4 times 5, but it's really 40 times 5. Now, 4 times 5 is 20, so 40 times 5 would be 200. We don't need to worry about the 200 though, because the units have already been sorted here. That other unit 0 is hidden behind this 5. So we can say 4 times 5 is 20. We have a 10 carried over here, which would turn 200 into 210. But of course, again, that 0 is still taken care of. So 4 times 5 is 20, plus the 1 is 21. And we get 215. Now, short multiplication, generally, most people are quite happy with. Doesn't seem to cause too much problem. Long multiplication allows us to do larger numbers. Let's stick with 43 on the top, but I will up this to 15. Now, this is where the long multiplication method is really straightforward and important to remember. So, we work at it in exactly the same way as we did over here. Everything on the bottom needs to be multiplied by everything along the top. And we start in exactly the same place. And let's ignore this 1 for the moment and remind ourselves of what we did over here. So I'm going to cover that up just because we're not going to think about that for the moment. The camera focus seems to be playing around. I apologize for that. 3 times 5 is, of course, 15. Now, you'll notice that I've done a little tiny 1 here because there's going to be some more numbers that come down under here. So I don't want this to be too large and in the way for when we write extra numbers in a moment. But I'm doing exactly the same thing. The 5 goes into the units, the 10 comes over. I'm going to cover that up again so we're not getting confused. Focus. 4 times 5 is then 20, as we did before, plus the 1 gives us 21. And it looks like that. This is where long multiplication differs. We move across now to multiply everything by the 1. Now remember, this 1 is in the tens column. If we're multiplying everything in the tens column, we have to make sure everything is 10 times larger. This is where what we all know as the placeholder 0 comes in. We have moved along our place value chart and we are multiplying not 1 times 3, but 10 times 3. To do that, we have to shift our place value chart along the bottom as well. So it's not 1 times 3, it's now 10 times 3. This 0 allows us to do that. Watch what happens. 1 times 3 is 3. But look what we've got written here. If we'd say this is a 10 times 3, we get 30. So the placeholder 0 has done its job for us. We then have 1 times 4, which is 10 times 40 in real life. 10 times 40 is 400. 1 times 4 is 4. We have our placeholder 0. We've already moved across. There's our 400, just with a 30 in front of it. So the placeholder 0 corrects for moving along the top. We've now got 2 numbers. They need to be totaled up to find the final answer. 5 plus 0 is still 5. 3 plus 1 is 4. 4 plus 2 is 6. And we have 645. Okay, let's do a couple more to check our method. So again, I'm just going to choose some random numbers off the top of my head. Let's have 27 and 34. Long multiplication. So every number on the bottom needs to be multiplied by every number on the top, and we have to be careful of our place value. So let's work it exactly as we did before. I'm going to ignore this 3 for the moment and pretend we've got a short multiplication to start with. So 4 times 7, 2 7s are 14, so 4 7s will be 28. If you don't know your 7 times table, that's quite a nice way to work it out. The 8 goes in, and I'm going to put a little tiny 2 down here because I'm going to put more numbers and I don't want them to get mixed up. Then we have 2 times 4, which is 8, of course. We have 2 more, which puts it at 10. So 4 lots of 27 will be 108. Now, what do we need to remember to do? We're now moving across to multiply by the 3. It's not actually a 3, it's a 30. So we need to increase our place value by a multiple of 10. We then have 3 times 7, which is actually 30 times 7, but we've put the 0 in here, so that will correct for it. So 3 times 7 is 21. 1 goes in, the 2 goes down. Then we have 3 times 2, which is 6, and 2 more puts it at 8. What do we do with our final numbers? We total them up, of course, giving us 8, 1, and 9. A final answer of 918. So every number on the bottom is multiplied by every number on the top and totaled at the end. Let's put some 3-digit numbers in. Ooh, a bonus mark. 465 multiplied by 43. Exactly the same routine. Every number on the bottom must be multiplied by every number on the top. Ignore the 4 for the moment and we'll work along. So 3 times 5, 15. 3 times 6, in this case, will be 18, and 1 more is 19. 3 times 4 is 12, and 1 more is 13. What do we need to put here? Because we're moving across to now multiply by 40 rather than 4, we must have our placeholder 0. Now, actually, in the arithmetic paper for Year 6 SATs, making sure that 0 is there is really important. That will hopefully get you a working mark in the Year 6 arithmetic paper. So really make sure that's there. If you miss that in the Year 6 arithmetic paper, you will not be allowed to get a working mark. So that's really important that that's there. Then we have a look at 4 times 5. Remember, it's not actually 4 times 5, it's 40 times 5 because we've moved our place value along. So 4 times 5 gives us 20. 4 times 6 gives us 24. And the extra 2 puts us at 26. 4 times 4 is then 16, plus the 2 gives us 18. We've got a lot of numbers here. Now we need to total them up. I will give you a little tip at this point. Be very careful not to use your little tiny carrying numbers from your multiplication. They are done. Forget those now. They have been taken care of. We're only looking at the main numbers for the addition. It's a little mistake that some people can make. Let's total it up. 5 plus 0 is 5. 9 plus 0 is still 9. 3 plus 6 is also 9. 8 plus 1 is also 9. And 1 on its own gives us 1, giving us 19,995, all the 9s. Okay, let's do 1 or 2 more, just to get our brains fully up to speed on this method. So, again, I'm just going to choose some random numbers off the top of my head. Let's see if all the 9s come out again this time. Let's have 3, 6, 3, and 41. Okay, same as before. 1 times 3, 3. 1 times 6, 6. 1 times 3, 3. Easy first row. Moving across to the 4. Remember, it's not actually 4, it's 40. So we must put our placeholder 0 in to cope with the place value shift. 4 times 3 then becomes 12. 2 goes in, 1 goes over. 4 times 6 is 24. And the 1 gives us 25. 3 times 4 is 12, plus the 2 gives us 14. Again, we're going to total, ignoring the little carrying numbers. They are done. Total up, 3 plus 0 is 3, 6 plus 2 is 8, 5, 6, 7, 8. Get all the 8s this time. And 4 plus 0 and 1 plus 0, giving us 14,883. That is essentially long multiplication. You can do it with zeros involved. Let's put a 0 in just to make sure we're nice and clear what we're up to. So we've now got a 0 placeholder in the top. Treat this exactly as you would every other number and work it through logically using the same method. Everything on the bottom multiplied by everything on the top. 3 times 7, 21. 7 times 0 is obviously nothing, because anything multiplied by 0 is still 0. We have an extra 2 to add on, so 0 plus 2 becomes 2. 9 times 7, if you remember your times tables trick, the 7th 9 is going to be 63. Make sure I got the pen around the right way. 7 9s are 63. Placeholder 0, because we're moving along. 2 times 3 becomes 6. 2 times 0 is obviously still 0. 2 times 9, 18. Total our numbers, ignoring the little carryings. 1 plus 0 is 1. 2 plus 6 is 8. 3 plus 0 is 3. 6 plus 8 gives us 14. Carry over. 1 plus 1 is 2. 24,381. There is one more that I want to show you. This is when we have a 3-digit number on the top and the bottom. Now, you can extend this method as much as you want. Those of you that are really interested in understanding this method, focus, thank you, will be able to extend this to as many digits as you want. And I have to say, it's quite fun when you have a lot of digits, but you've got to make sure you're being very accurate with your times tables. The more steps you have, the more likely you are to make a working mistake, and to go back and find it can be quite tricky. So again, I'm just going to choose some random numbers off the top of my head, which I like to do. Let's have 3, 6, oh, I've got 3, 6 again. Look at that. I wasn't doing that consciously. Right, I'm going to change the 3 then. Let's have 3, 6, 8. And we will have 2, 6, 5. Now, those of you that are thinking logically may have worked this out already. Let's work it through. Everything on the bottom multiplied by everything on the top. 5 times 8 is 40. 5 times 6 is 30, and the 4 is 34. 3 times 5 is 15, plus the 3, 16, 17, 18. Placeholder 0, because we're moving across. 6 8s. There's a good one. 6 8s are, shout it out at me, are 48. 8 in, 4 over. 6 6s are 36, plus the 4 is 40. 3 6s, 18, plus the 4, 22. We've still got another digit to play with. We've now moved 2 places in our place value chart, so we do have to put in 2 zeros, because this is 200 times everything on the top. So 2 placeholder zeros are required. 2 8s, 16. 2 6s, 12, plus the 1 is 13. 2 3s are 6, plus the 1 is 7. Just as before, total everything up. All the zeros down that column. 8, 9, 10, 11, 12 there. 8, 9, 10, 11, 12, 13, 14, plus 1 is 15. 3, 4, 5, 6, 7. 7, 8, 9. Giving us a grand total of 97,520. That is long multiplication. If there are any other requests for other maths videos, let me know. I will be happy to see what I can do. Have fun, have a play, and enjoy.